In this video segment, we're going to study the signs of the trig functions, as in positive or negative, in terms of all four quadrants, so Roman numeral 1 through Roman numeral 4. Just a reminder, we learned in our previous material that the sine of an angle was defined as the side opposite over the hypotenuse, and the cosecant was the hypotenuse over the side opposite. They are reciprocal functions. We studied this in a way to compare it to an angle whose terminal side was in the first quadrant. Let's just throw a line here in the first quadrant. And we looked at this right triangle that was formed, and we called this the side opposite, this angle theta. This is the side adjacent to that angle theta, and this is the hypotenuse. We also went on to say, let's think of the side adjacent as side x, and the side opposite as side y, and the hypotenuse as side r. And so we defined the sine of an angle as y over r. The cosine of an angle is x over r because it's the side adjacent divided by the hypotenuse, again, which is x over r. And tangent, defined as the side opposite over the side adjacent, and over here in my picture the side opposite is y, the side adjacent is x, and we have that y divided by x. And we went ahead and learned and came to understand that the sine, cosine, and tangent of an angle are just a fraction. They are just a ratio, a relationship that's true for any given angle. So if I were to draw an angle in the first quadrant whose terminal side passes through the spot where x is 5 and y is 12, I would go to the right 5 and I would go up 12. And so the angle we're speaking at is about, it's kind of a large angle, I don't know, maybe I'm going to draw that with a straight line, maybe a 66-degree angle or something like that. I'm going to drop a perpendicular to the x-axis, and I'm going to label this angle theta to have a leg that is 5, another leg that is 12, and by the Pythagorean theorem, a hypotenuse that is 13. And you can just check this out each time, because 5 squared plus 12 squared you would find is equal to the 13. We could define the sine of theta, let's do it in terms of x, y's, and r's, as y over r. So in this picture, in this ordered pair, my y value is 12, or my y value, or my side opposite is 12 over the hypotenuse, 13. I just want you to notice that that answer is a positive answer, 12 over 13. It is just a ratio. The cosine of theta is defined as x over r, and over here in my ordered pair, x is 5, or right here, x is 5. My hypotenuse is 13. 5 over 13. Just want you to notice that that fractional answer is a positive answer, and that the tangent of theta is defined as y divided by x. Well, x and y in the first quadrant are both positive numbers. That is 12 divided by 5. So again, positive results. So we have seen, but we really haven't paid much attention to the fact that the trig functions in the first quadrant are all positive, and so is it true that their reciprocal functions are as well. But let's go to the second quadrant now, and let's look at an angle whose terminal side passes through the spot where x is a negative 3 and y is a positive 4. So I'm going to go to the left 1, 2, 3, and then I'm going to go up 1, 2, 3, 4. I'll put a dot about right there. So I'm speaking about this angle whose terminal side passes through that ordered pair right there. Again, remember this ordered pair, x is a negative 3, y is a positive 4. However, if I refer to what's called a reference triangle to describe this angle, I can notice that yes, this x value I go left 3, this y value I go up 4, but when I put that negative 3 and that 4 into the Pythagorean theorem, I get a positive 5 for the hypotenuse. That's because if you take that leg of a negative 3 and square it, you get 9. If you take the leg called 4 and square it, you get 16. And 9 plus 16 is 25, and the square root of 25 is 5. More importantly, though, I want to go over here and define sine, which is y divided by r. And in this ordered pair, or over here, my y value is 4. Or right here, my y value is 4, and my r value is 5. And I see that sine of that angle, whatever it is, it looks to me like it's a 120-degree angle. I think that the sine of that angle is going to be a positive number. I don't care that it's 4 over 5. I just want you to notice that it's positive. The cosine of an angle is defined as x over r. So come on over here to this ordered pair. Notice that in the second quadrant, remember I'm in the second quadrant, my x value is negative. That's this negative 3 over the hypotenuse of 5. So I write the ratio for cosine, and would you just notice that that results is negative. And then let's write the ratio for the tangent of an angle, which is defined as y divided by x. And come on over here to the ordered pair. Notice your y value is 4, or it's this positive 4, over the hypotenuse of 5. And tangent is, I'm sorry, I said hypotenuse. I meant it's y over x. So it's 4 over a negative 3, excuse me there. And would you just notice that the response for the tangent of an angle in the second quadrant is negative? Most importantly, what I want you to notice is that sine in the second quadrant is positive, and therefore, of course, so is its reciprocal function, because it's just defined as r divided by y. And in the second quadrant, y is still positive. So you have a positive number divided by a positive number. Again, the reason for this, the reason that cosine and tangent are negative in the second quadrant is because they contain an x value. And the x value in the second quadrant is negative, right here and right here, even though the r value and the y value are both positive. Let's go on to our next page, and let's talk about an angle that's in the third quadrant. So let's take a look at an angle whose terminal side passes through where x is a negative 6. So let's go to the left 6 and then down 8. So something bigger than 180 degrees. I'm going to draw the terminal side out to that ordered pair. So again, this spot x and y are both negative, but when I put those into the Pythagorean theorem, I'm going to create this reference right triangle. When I put those numbers in to the Pythagorean theorem, they cause this hypotenuse to be a positive 10. So it doesn't matter that this is a negative 6. And then I go down a negative 8, my hypotenuse is 10. So let's go back to the definitions of sine, cosine, and tangent. And let's notice that in the third quadrant, it ends up that sine turns out to be negative now. Please remember, a minute ago in the second quadrant, it was positive. Sine is defined as my y value, which is this negative 8, divided by my r value, negative 8 over 10. Yes, I can reduce that to negative 4 over 5. Yes, I can call that a decimal number, a negative 0.8. But really, what I really care about right now is I want you to notice that the sine of an angle in the third quadrant is negative. Cosine is defined as x over r. And because in the third quadrant, x is also negative, in this case a negative 6 over the r value of 10, or if you wanted to reduce it, a negative 3 over 5, or a negative 6. But what I really care about is I want you to notice that cosine is negative in the second quadrant. But voila, we come to tangent, which is defined as y divided by x. And look at these two numbers. Both x and y are negative in the third quadrant. So when you take that fraction or that ratio and you display the negative 8 divided by the negative 6, you say to yourself, a negative divided by a negative is a positive. Yes, I can reduce that to 4 over 3. Yes, I can call that 1.3, but I want you to notice that the tangent and its reciprocal function, cotangent, are positive in the third quadrant, and that's because for both of those, they are a negative divided by a negative. Again here, a negative divided by a negative. I want to start to summarize, and I'm going to do that way down here. So we know that all the trig functions are positive in the first quadrant. We have just discovered that sine and its reciprocal function cosecant are positive in the second quadrant. And then just 1 minute ago, we discovered that tangent and cotangent are positive in the third quadrant. Please notice this is where the trig functions are positive. The trig functions are positive in two places. Always in the first, sine is positive in the second as well. Tangent is always positive in the first, but also positive in the third as well. Let's go back up here to this problem where x is 12 and y is a -5, and let's take a look at that fourth quadrant angle. So if I go to the right 12 and down 5 and put the terminal side in this fourth quadrant, and then if you don't mind, I'm going to draw the reference right triangle. We'll be referring to that in the future a little bit more. This ordered pair, the x value is 12, the y value is a -5. The side, if you will, in the reference right triangle is a +12 because I go to the right 12 and then down 5. And by the Pythagorean theorem, my hypotenuse is 13. So I go here and I look at the sine, the cosine, and the tangent again. And in terms of y divided by r for sine, well, my y value in the fourth quadrant is a negative number. And in this case, it's a -5. And my hypotenuse is 13. Mostly, I want you to notice that sine, the value for sine of an angle in the fourth quadrant, is a negative number. Cosine, however, is defined as x over r. And in the fourth quadrant, the value for x, right here, this 12, is a positive number. And the hypotenuse is always positive, remember, by the Pythagorean theorem. So, gosh, we haven't seen cosine show up as positive until now. But it looks like in the fourth quadrant, cosine will be positive. Let's go to tangent. Tangent is defined as y divided by x. In this fourth quadrant, my y value is a -5, or this -5. So I have a -5, and my x value is a +12 in the fourth quadrant. And so a negative divided by a positive is a negative. So would you again notice that two of the trig functions are negative in the fourth quadrant, and their reciprocal functions. Only cosine and its reciprocal, which is secant, which is defined as r divided by x. And that's because in the fourth quadrant, x is always positive, and again, the hypotenuse is always positive. So we complete this table, and it says that cosine and secant will be positive in the fourth quadrant. Let's go ahead and put our Roman numerals in here. And sometimes people refer to this idea or this concept as the Zorro effect. And I'm going to use a highlighter. Starting in the first quadrant, all the trig functions are positive in the first quadrant. And I usually state the definition of sine first when I list the three trig functions, and sine is positive in the second. Cosine is positive in the third, and tangent is positive in the fourth. So many people call that the Zorro effect. So again, all, sine, cosine, and tangent. And again, here I'm just referring to the three main trig functions. We're going to now practice and try to identify the signs of the trig functions based on the size of the angle in our next segment.